say like area of ABC, triangle ABC is less than area of sector ABC is less than area of triangle ACD, right? Now what are the values? The values are sine theta by 2 is less than theta by 2 is less than tangent theta by 2. Okay, now what happens here is we can get rid of these halves because they are all equal. So getting rid of these all halves, we will get sine theta is less than equal to theta is less than equal to tangent theta, because our goal is to make something like sine theta over theta. Okay, so we have to modify this. To make this theta as the denominator, we can flip this whole order. When we flip this, what we will get is 1 over sine theta, and when we flip this, the inequality signs will change now. It will be greater than 1 upon theta will be greater than 1 upon tangent theta. Okay, and we all know that this tangent theta is cotangent theta, and which is cosine theta over sine theta, right? So now to make this one sine theta over theta, we can multiply this whole equation with sine. By multiplying this all with sine theta, what we will get? We'll get 1 greater than equals to sine theta over theta greater than equals to, we have cosine theta over sine theta times sine theta right here. So sine theta will get cancelled and it will be cosine theta now. Now we got this form, right? Now what we will do is we will now apply the limit now. What is the limit? Now we will apply this 1 limit theta approaches to 0 greater than equal to sine theta over theta limit theta approaches to 0 greater than equal to cosine theta limit theta approaches to 0, right? Now for this, let us consider that this theta is approaching to positive 0, okay, here, because we have to check it for the other way around when the theta is less than 0 as well as theta is greater than 0, which is theta is positive and theta is negative, because when we take the limit it holds true for both the values. Okay, while taking for the theta positive, which means theta is greater than 0, what we will get? We will get that when it appears 0, it will remain as 1 only because it is independent of the limit, right? And this is the thing that we are going to find. Sine theta over theta limit theta approaches to 0 is greater than equals to this one. See, when theta approaches to 0, this cosine theta will approach to cosine 0, and cosine 0 is also 1. Okay, now we got this very important result. Okay, now from this we can say that the limit of this expression is sandwiched between 1 and 1. Okay, so in this case we can make use of squeeze theorem to determine the limit. From the squeeze theorem we have that if f of x is less than equal to g of x is less than equal to h of x, okay, these all are the function of x, but h is the greatest and f of x is the least. Okay, then when x is near a, which means x is approaching to the value a, then also that we find the limits as c. Limit of x approaches to a, f of x is equals to L, and limit of x approaches to a, h of x also is equal to L, then the limit of x approaches to a, g of x should be equal to L. Okay, because you can see that this sandwiched between this h of x and f of x, right? And the limit of these are equal, which L and L, which means this function will also have L. So this case is exactly same here. Okay, so if you flip this to make this kind of arrangement by switching this order, okay, we will get 1 less than equal to sine of theta upon theta limit theta approaches to 0 is less than equals to 1. Okay, it is same because this L and L, so they are equal, which means that finally this limit of sine theta divided by theta when theta approaches to 0 is indeed 1. Thus we have proved that limit of theta approaches to 0 sine theta over theta is equals to 1 by using Squeeze theorem and unit circle. So this is very important result, okay, and you will need it when we derive the proof for the derivative of sine with respect to x is cosine x. Okay, now the second part of the proof is this one, limit 1 over cosine theta divided by theta when theta approaches to 0 equals to 0. So we will prove this together because we can make slight modification to this limit and we can get the result. Okay, and notice that this one is for theta greater than 0, but we will apply the same thing after deriving for cosine to evaluate for the theta less than 0, which is approaching to a negative. Okay, now for this, initially we have limit theta approaches to 0 sine of theta divided by theta equals to 1. Okay, now what we can do is we have to make this in terms like 1 minus cosine theta. Okay, because see, like whether you use theta less than greater than 0 or theta less than 0, cosine of negative theta is equal to just cosine theta. It does not change with the sign, so the value doesn't change when you switch this order. Okay, now let us square on the both sides. Okay, so we will get limit theta approaches to 0 sine of theta upon theta whole square equals to 1 square, right? 1 square is 1 itself. Now why we have made this is because we have to change this sine theta into cosine theta. We have the trig identity that cosine square theta plus sine square theta equals to 1, which implies sine square theta is equals to 1 minus cosine square theta. So this is very important trig identity. So we will use this here. We will have this theta approaches to 0 sine square theta, right, divided by theta square equals to 1. So we can substitute here by 1 minus cosine square. Limit 0 approaches to 0, 1 minus cosine square theta divided by theta square equals to 1. Right. So if you notice this very carefully, this is the difference of the square, which is in the form a square minus b square, right? 1 square minus this one. So we can write this in the form a plus b times a minus b. So we can modify this and write in terms of this one. We will have theta approaches to 0, 1 plus cosine theta, 1 minus cosine theta divided by theta square equals to 1. So as we have already seen that the limit of the product is the product of the limit, so we can distribute this limit to each of the component. So by distributing the limit, now we will get that limit theta approaches to 0, 1 plus cosine theta upon theta. Okay, limit theta approaches to 0, 1 minus cosine theta upon theta, okay, equals to 1. So now from here you might have noticed that this is exactly what we are looking for here in this expression, so we can shift this side and take the reciprocal of it, because from the limit rule we also know that the reciprocal of the limit is the limit of the reciprocals. Okay, so we can take the reciprocal and we'll get limit theta approaches to 0, 1 minus cosine theta upon theta equals to, so we can take this here and we'll get theta upon 1 plus cosine theta when theta approaches to 0, because the limit of the reciprocal is the reciprocal of the limit. If you take the reciprocal here and take the limit, or if you reciprocal this and take the limit, it will be equal. So by doing this, now we know that limit of theta approaches to 0, 1 minus cosine theta upon theta equals to C. When theta approaches to 0, this theta becomes 0 upon, and cosine also when it approaches to 0, when theta approaches to 0, cosine is 1, right? So it will be 0 upon 2, okay, which is simply 0. So which is 0. And from here we have derived the second result, that limit of theta minus theta approaches to 0, 1 minus cosine theta divided by theta equals to 0. So now let us check for the theta less than 0, which is when theta approaches to the negative 0 side. So for this we have limit theta approaches to negative of the 0 sine of, see, negative theta upon negative theta, okay, when it approaches to negative 0 side from here. For example, this is 0 and 1, 2, negative 1, negative 2. Like when it, for the positive, it will appear from this positive side to 0, okay, 0 plus. And for this case, it is the theta value is appearing from this side, from negative side. So we are, when we take this negative sign, we are saying that the theta value is decreasing from the negative side. From this, then the theta value will be negative, and we know that sine negative theta is negative of sine theta upon negative theta. Theta approaches to 0, which will be 1, because negative will get cancelled. And even for this cosine, when we approach this from minus, okay, then what will we get? We will get this cosine value, cosine minus theta is equals to cosine theta, right? So the sign doesn't change here. What we will say is 1, which will be equal to limit of theta approaches to 0, 1 minus cosine theta and negative theta. So if you just shift this negative sign here, then we can write this in the form limit of theta approaches to 0, cosine theta minus 1 upon theta. So now we got all the expression for these limits, and it will be very useful in the later videos when I derive the differentiation for the trig functions. Lastly, we can say that it is approaching plus or minus, right? But here it is plus, and which will be equal to cosine theta minus 1 upon theta limit theta approaches from minus 0. Okay. I hope you have enjoyed this proof, although this video became long, but you might have understood and enjoyed the beauty of the math. I'll see you next video when I begin deriving the result for the differentiation of the trigonometric function like sine, cosine, tangent, cotangent, cosecant, secant, then the hyperbolic functions like cos, sine, hyperbolic version of sec, tan, etc. Okay, thanks for watching and I will see you in next video.